Welcome back, fellow space voyagers, to day 5 of the Pihut's Maker Advent Calendar 12 Projects of Codemas. Let's get right on into it. Alright, time for the unboxing of day 5. Alright, looks like we have one custom pre-wired buzzer with metal jumper wire ends. Alright, Maker Advent Calendar day number 5. Here my code. Maker Advent day number 5. Alright. Welcome to day 5 of your 12 Projects of Codemas Advent Calendar. Today we'll be making sounds with our code using the custom buzzer you've just discovered in your box. The buzzer is nice and easy to wire into our circuit using just 2 pins with no other components required. You can add so much can add so much to a project. Adding audible feedback for errors, button presses, and other actions gives your project a whole new dimension. Let's make some noise. Box 5 contents. As we just saw, we got the custom pre-wired buzzer with metal jumper wire ends. Today's project. Today we'll be using our buzzer in a few different ways. First, for simple beeps and tones, and then combining with our potentiometer to control the volume. Then finally something a little more advanced where we use different frequencies to generate festive tones. This particular buzzer works with PWM signals to allow you to generate different tones, so we'll be tapping back into everything we learned about PWM in yesterday's box. It's almost like we planned this. Construct the circuit. Remember to unplug your Pico from your USB port before amending the circuit. We'll be using the potentiometer from yesterday's box to control our buzzer in a few moments, so leave your circuit in place as it is. We just need to add our buzzer and we're good to go. This is one of the easier components to work with, as we've included a custom pre-wired buzzer with metal jumper wirings. Simply push the red wire into GPIO 13 or physical pin 17 and the black wire into the ground pin next to it, which is physical pin 18. Alright. So ground into 18. Alright, should be good. Activity 1. Let's buzz. Our buzzer can generate different tones based on the PWM frequency and duty cycle we use in our code. This should sound familiar as we've covered PWM yesterday. PWM frequency and duty cycle with buzzers. The frequency here changes the tone of the buzzer. We found that our ears can detect changes in the tone when using values between 10 and 10,000. The duty cycle sets the volume of the buzzer. The range is technically 0 to 65535 in MicroPython. However, we find that values below 5,000 are very difficult for our ears to hear. A duty of 10,000 appears to be the sweet spot for our buzzer. If you want to silence the buzzer in your code, just set the duty to 0. Easy. The code. Now we know what the PWM values do here. Let's try a quick example where we sound the buzzer for a few seconds. The example below includes the same ingredients you're now becoming familiar with: imports, pin setup with the PWM duty cycle, and frequency. So there's nothing new or scary here, and our usual slightly excessive code commentary tells you what each line is doing. We set up the pin for the buzzer, then assign a frequency 1000, and finally set the PWM duty volume to 10,000 for a second, and then draw back down to 0 to mute it. Nice and easy. Copy the example over to Thani and give it a go. Sheesh. All right. All right. Well, that worked. So let's see, from machine import pin PWM import time. So set the buzzer to PWM mode, set the frequency to 1000, set the duty and then wait for 1 second and then turn to 0 to turn the buzzer off. Now try changing that frequency number to 300 and see what happens. We'll go to 9,000. Alright, now I'm not sure if you could hear that one. Alright, cool. Activity 2, changing tones. Here's another simple example just to show you how easy it is to change the tone on your buzzer from one to another. Here we start with the frequency of 1000 for 1 second and then drop it down to 500 for 1 second. Give it a try and hear it for yourself. All right. Activity 3, potentiometer volume control. Let's use one of the previous components to control the volume of the buzzer. This one's a bit noisy and not perfect. The sound can distort or cut out at high levels, but it's a fun project to try out. If you find the buzzer a bit loud or harsh, you can always place some sticky tape or a blob of blue tack over the hole to calm it down. The readings from the potentiometer are between 0 and 65535, and our buzzer duty or volume uses the same range, so we can use the potentiometer readings to directly control the duty. In the example below, in each while loop, we take a reading from the potentiometer and store it in a variable called reading, just like we did yesterday in activity 3. And then we use this variable as the buzzer duty value instead of adding a number there ourselves. A little warning, this example will never turn the buzzer off even if you stop the program, as this is a quick basic example first to get familiar with our buzzer control. You can unplug the USB cable to stop the noise or just move on to the next activity. All right, let's run it. Alright, hopefully that's not too annoying to just leave running. I guess I could... Okay. Well, that was a spoiler for the next one, but... Activity 4, festive jingle. How about a little festive tune with our buzzer? By changing the frequency between each pause, we can create a tune that resembles a popular festive jingle. A nice way of doing this is to define each musical note frequency as a variable using the note name, which will make our code easier to write, read, and review. We've covered variables before, so this should be familiar. We've also used a variable for the volume or duty cycle, as again it makes our code a little more human. Don't worry, we've included the tone values for the jingle below for you. The example below is purposely inefficient and uses a lot of lines, mostly because each section of the jingle includes lines to turn the volume on, then off, as well as delays. Try this first, then we'll move on to a nicer way of doing things in the next activity. We've included commentary on the first jingle block of code to show you what we're doing here. Tip, this is a simple buzzer, so it doesn't quite have the smooth sound that a normal speaker will create. The buzzer can sound a little more Nightmare Before Christmas than Elf. Alright, so here's where we set the notes as variables, or set the tone variables, which are corresponding to the notes for the song. Create the volume variable. Activity 5, festive jingle using functions. Let's improve the very long code above by introducing something new, functions. Functions are blocks of code that you can create and then call or use at any time in your program. They're great for repetitive blocks of code as it keeps your program short and efficient, which can be important if your microcontroller has limited storage. Let's explain how functions work before we move on. Writing a function. Below is an example of a function that prints 3 lines. We create a function by printing def followed by a space, and then the name we want to give our function. No spaces in the function name. We've called ours my function. You then add brackets or parentheses at the end, which can include any arguments if required. We're not using any in this example, but we cover them in a moment, followed by a colon. Indentation is important again here. Everything under the def line must be indented to indicate that it's a part of the function. So there's an example there. Using functions. So now that we have a function, how do we use it and why is it better than just writing the code? We can call or use the function by simply using the function name followed by brackets like this. So why is this better? Let's look at 2 examples below where we want to print a set of strings 3 times. Both of the following examples have the same outcome. Try them yourself. However, the code using functions is shorter. It might not look like much in this example. However, in large projects, this can save a lot of lines in your code. It also makes it a lot easier to update your code as you only have to amend the one function, not every part of your program. Example without a function and an example with a function. All right, function arguments. We mentioned arguments earlier, so let's talk about them quickly before we move into our jingle example. Arguments are optional in functions. They allow you to pass information into your function if needed. We pass the information to the function when we call it. That might be a bit confusing, so let's jump to an example so you can see it working. In the example below, our function prints 3 lines again, but this time we include arguments asking for the first name, middle name, and surname. As we might want to change the names each time we call this function, those arguments are used in the print lines as you can see below. Now to call the function and pass the names to it, we add the names in the same places inside the brackets, making sure we enter them inside inverted commas as we're dealing with strings here. Try this yourself, then try adding a 4th argument and printing a 4th line to go with it. All right. The code. Now we know how functions work. Let's apply them to our jingle example to see if we can reduce the length of the code. The example below uses a function called playTone to handle all of the volume changes, delays, and notes. All you have to do is add the arguments for each. Our arguments are note, the note to use, vol, the volume, delay 1, the first time.sleep period, and delay 2, the second time.sleep period. The code is roughly half the number of lines and does the same thing, much better. Okay, well that doesn't sound the same. Alright, so that's interesting that they changed that. Bonus, more notes. Chris E. kindly added a comment below providing a nice full list of notes, including sharps. Look up your favorite songs, use these notes, and get creative. Thanks, Chris. Alright, well, that's all the time we're going to waste on that. Day number 5 complete. We've covered lots today, fellow makers. Pat yourselves on the back. As we cover more advanced topics such as functions, you may find that you need to refer back to these days to refresh your memory later on, and that's absolutely normal. Even the most seasoned professional programmers have to use search engines regularly. Some even admit it. So what did we cover on day 5? Today you have built a circuit with a buzzer, your first audio component, learned how to use the buzzer with MicroPython and the Pico, learned about PWM frequencies and duty cycle with buzzers, used analog inputs to control audio volume using PWM, created a festive jungle with MicroPython, and learned how to use functions to make your code easier to manage and more efficient. Keep your circuit safe somewhere until tomorrow. Don't take anything apart just yet. As always, thanks for stopping by, and come back tomorrow.